Hi guys, Krishna here. In continuing with our discussion on the Azure Stream Analytics, in this section we're going to look into the structure of the Stream Analytics. So when you talk about structure, what I actually mean is what are the components within the Azure Stream Analytics, and look into key features like operators and SQL queries, and also have a touch base on one of the fundamental concepts about timestamps. So let's get started. So what is Stream Analytics basically? So Stream Analytics is basically a fully managed PaaS space system. So what we mean by that is there is no need to install any type of servers or configure any type of large infrastructure to get your service up and running. And fundamentally, because it's a PaaS service, the systems are built with high resiliency and fault tolerance. And more importantly, one of the fundamental feature of the Azure Stream Analytics, it provides a SQL-like query language. With that, you can basically query the data, and it also reduces the I would say the learning curve for a developer that's starting to use Azure Stream Analytics, which is in other words called developer productivity, which is fundamentally important when you're getting any type of technology to get adopted. So I want to focus now on the structure of the Azure Stream Analytics. So as we previously saw, there are three key components here. One is the input, the process, and the output. The input, it currently accepts three types of input. It might change in the future, but as of today it accepts Azure Event Hub, IoT Hub, and Blob Storage. If you look at why these three, if you take a bit more deeper look, so these three are massively scalable, highly resilient, with I would say high throughput systems, which means event hubs can ingest couple of thousands or even millions of messages, and these can scale exponentially as the data grows. Same thing with Blob Storage, same thing with IoT Hub. The process is a very interesting piece because the process is where all the magic of the stream processing happens. The stream processing engine pretty much runs out of the memory. Why memory is basically to reduce the latency that is brought in by the disk read write. So immediately, because you're running in memory, you're getting a massive boost on it. And other key concept I also want to highlight is the jobs or the process, I would say, are run massively parallel. Because you're running massively parallel, you are getting this high velocity throughput. So a job can be split into multiple smaller chunks, and all of them process parallelly, which means the time to taken to complete a given job or process is much shorter. Okay, so we have a nice highly scalable input and a fantastic process engine. What about the outputs? Outputs also a very key point. So if you look at the types of output, pretty much it supports starting from blob storage, table storage, SQL databases, Azure Data Lake Store, Event Hubs, Power BI, Cosmos DB, Azure Functions, currently it's in preview, service topics, and service bus. If you notice, what's happening here is we are giving you multitude types of output so that you can take the process input and push it to any system you want. So this gives you a very clear picture on the structure of the Stream Analytics system. As you can see, it's very versatile. It accepts multiple types of inputs and process pretty much extremely powerful, and also the output. So this gives you, I hope this gives you a very good understanding about how this Azure Stream Analytics is structured.